Hey guys, Miss Saltstein here. In this unit, you're not really going to be doing anything new. And I just wanted to point out kind of the big idea why you're doing this, and then one little thing that you need to remember to be successful. Okay. So the big idea here is that sometimes we're going to just kind of estimate or approximate because it's not worth it to get into the details of exactly how much or how little something is. Okay. And we do this all the time in ordinary life. The example that I think of is when we say, oh, they're a millionaire. Okay. They could have $1 million. They could have 9,999,909. Okay. We don't really know beyond that, but we know they're a millionaire, so we know a range of values that it could be in. And it gives us a close enough idea of this person's wealth versus, oh, he's a billionaire, okay, or she's a 100 billionaire, right? That gives us a whole other idea. And that's kind of what your curriculum's talking about here when they say this word magnitude. Okay, so the magnitude, let me zoom in on this word magnitude, is just sort of this rough idea of how big something is. Okay, they've got about $1 million. Oh, they've got about $1 billion. Okay, we don't need to know the details. Um, all right. So if we look at these problems here, that was the big idea, and then this is the important thing that you need to remember is that in negative land, with the exponents, just like with the integers, the bigger the negative, the smaller the number. -1, -2, -3, and all the way to negative infinity. So on the number line, we already know this. The further to the left of 0, the smaller you're getting. So -2 is in fact smaller than -1. Still true with exponents, okay? So if you look at this one, compare um, the exponent of -24 is smaller than 10 to the -23rd power. Okay, just like the integer -23 is actually bigger than -24. So don't forget about that. Okay. And then here, this is the same kind of thing, but they're gonna throw some real world things on it. So we've got a plant cell and a red blood cell. Okay, they're giving us the approximate size of it, and they're asking which cell has the shorter, meaning the smaller radius. Okay, and so for the smaller number, we are going to look at the greater negative. That's actually smaller. So because -11 is less than -6, that means that the plant cell is actually kind of a lot smaller, right, than the red blood cell. Okay, so that's interesting. But anyway, this chart up here is kind of cool. I like the look of it, the patterns in it. But so you can see here as the negative exponents get bigger, the number gets smaller and smaller and smaller. See, it's like a tenth, 100th, 1,000th. Okay, and then they start going by threes here, right? 1,000 to million in, our normal numbers would be going from the third power to the sixth power. So here we go from the -3rd power to the -6th, and we go from 1,000th to 1 millionth. Okay, and then to a billionth and a trillionth and a quadrillionth. And now you're talking about really, really tiny numbers because look at all these zeros to the right of the decimal point before we get the 1. Okay, so big idea here. Sometimes we don't need to know exactly what the number is. We just kind of need to know its magnitude, meaning millionaire, billionaire, trillions of debt. Okay. And then the other thing that we want to remember is that in negative land, the bigger numbers are actually smaller.